Okay, so this is my parabola project. My equation is y equals 0.92x squared minus 1.83x minus 13.75. So my equation helps the opening because the parabola it opens upwards because it's positive, because A is positive, 0.92 is positive, so it opens upwards. And the axis of symmetry is right here, down this line right here, which is also the x value of the vertex. So the equation for the axis of symmetry would be, well, the formula is x equals negative b over 2a, and so my work, I put the b value over 2 times a, and then I got the axis of symmetry, which rounds to 0.99. So how do the two values that you found for the axis of symmetry, regression values versus your graph, compare? They compare because when the axis of symmetry is plugged in as x in the quadratic regression equation, it gives us the y value, which is what I did right here. And when we get the y value, that gives us the vertex. As we can see on the graph, the axis of symmetry right here and the vertex right here, everything can now be concluded since we have a vertex, which is how I found the other surrounding points and the x-intercepts as well. So the y-intercept is right here. To find the y-intercept, we look at the c value of the quadratic equation, which is right here. So our y-intercept would be negative 13.75, which there's a dot right here. The x-intercept can be found by using intercept form. The intercept form is y equals 0.99 parentheses x minus 4.99 parentheses x plus 3. So the zeros of the quadratic equation are negative 3 and 4.990. So the vertex is right here. To find the vertex, what we do is, using our x value from the axis of symmetry, we plug it in to the quadratic equation, and then we solve, and here's all my work, and that's how we found the y value. So now we have our vertex, 0.99 and negative 14.66. Then we also have our minimums. Since a is positive, we have a minimum. If a was negative, then we would have a maximum. Our y coordinate tells us what the value is from the vertex. So the minimum value of our quadratic function is negative 14.66. That's the y value of the vertex. So to summarize my findings, a picture represents and behaves as a parabolic function because it not only has the shape, but the points, all the points could be found, and all components such as the vertex, the x and y intercepts, and everything like that could be calculated and was accurate. My regression equation could have been more accurate if my parabola would have been more skinnier and more fitted and not as round on the bottom, and if I could have been able to find perfect whole number points or choose another example of a real life parabola.